Hello everyone, welcome back. So in today's session, let's continue our discussion on generative AI concepts. So in today's session, let's focus more on generative AI in the machine learning landscape. So let's get started. Okay. So first, let's try to understand what is the meaning of discriminative model and the generative model. So from this, you can easily guess that. Okay. So assume like you have the data set which has the cat and dog images. Okay. If I try to fit that into my discriminative model, so model will just try to classify whether it's a cat image or a dog image. Okay. So what is generative model? So we have some kind of data that has been trained. Okay. So for the generative model, and I ask the model to generate a similar content. Okay, like a cat image sorry, a cat content, cat image or a dog image. Okay, so then then the generative model will generate that particular image. Okay, so this is what the definitions is. Okay, so in simple terms, so discriminative models are types of models that focus on distinguishing between the different classes or the categories in the data. Okay, so it's similar to this. Okay, so if you have cat and dog, so discriminative model will try to discriminate whether it's a cat image or a dog image. So they learn to tell the difference between the classes rather than learning how the data is generated. Okay, so this is all about the discriminative models. So these are the examples. Like imagine you have a bunch of images of cats and dogs, and you want a model to tell you whether a new image is a cat or dog, right? So this is one of the example. So a discriminative model will learn the boundaries or the differences between the cat images and dog images based on their features like color, shape, right? And based on these features, then it will try to classify whether the given image is a dog image or a cat image. So in other words, so discriminative models answer the question like, given these features, which category does this data belongs to? Okay, so this is what the meaning of discriminative models is, right? And these are some of the examples of descriptive model like logistic regression, support vector machines, even the neural networks, okay, which is used for the classification task. So this is more about descriptive models. Okay, assume like we have a bunch of images of um, a puppy as well as the bagel. Okay, so the model will try to tell whether this image after the training, right? So it will able to answer the question whether this given image is a puppy or a bagel, right? So yes, this is another examples. So descriptive models are the class of a machine learning algorithm designed to learn the boundaries between the different classes or categories in the given data set. And these models focus on directly mapping input features to the output labels, so making them particularly effective for the classification and the regression task. So this is all about the discriminative. So generative is basically we have the data. Okay, so the model which has got trained, okay, it will able to generate the new content. Okay, so this is what the difference between the discriminative and the generative model is. So as I told you, it's the same thing, right? So if we have the set of images of puppy and the bagel, okay, in the discriminative model will try to learn the features and the patterns of the images, right? And so whenever I have the new image, then the model will classify whether it's a puppy image or a bagel. uh, so yes, that's what. So we gets with the confidence. Okay, so this is just an image representing the discriminative model. But so what is generative model now? Okay, so generative model is all about like we have already trained the model, okay, with a bunch of cat and dog images. Okay, it's a lot of data that has been trained. Okay, and I asked the model to generate some new content, okay, based on the training which has had. Okay, so like for example, if I tell okay, one puppy please, it will try to generate a new content. I mean like the new image of the puppy, right? So this is how the generative models look. Okay, so not only that, okay, so it could be anything. Okay, if I ask the models to generate some magazine images, right? So it will try to create a new magazine cover, right? And basically give the new content. Okay, so this is what the generative model is. So next we have something called generative adversarial networks. Okay, so this is just a foundation for my generative models because GANs is very popular. Okay, it was very popular. Okay, and whatever the generative models right now is showing, somewhere it started with the generative adversarial networks, right? So they have the architecture like this, right? So they have something called generator and the discriminator. So first what we'll do is we have the set of sample data, right? So we have set of sample data. So then we have something called a generator. So generator will generate some fake images. Okay, and then we have a real sample data that is basically sent to my discriminator. So now the discriminator will able to identify whether the data which has been given, okay, whether it's a generated or it is a true real data. Okay, so if it is able to guess the generator image, okay, so then it's performing, then we can say that the model is performing better. Okay, and so then just what it will basically check the condition, whether the condition is correct or not, and if not, then we'll try to fine tune the discriminator, and this is how the training happens. Okay, so there are the different components when we have something called generator and we have the discriminator. So we have it, this is another image, you can see here we have a training set. So that training set is basically sent to a discriminator. On the other hand, we have the generator, which will basically try to generate some fake images. So then this discriminator will try to tell whether it's a real image or fake image. Okay, so based on that, so it will again fine tune it. Okay, and this process continues. Okay, so this is what, so the again model will try to tell that I'll trick you, but discriminator tell no way. Again, this is how the learning process happens. Okay, so yes, so these are some of the examples, okay, of the GANs. Okay, yes, so these are these few more examples. So generator will generate the fake data, and we have the real data. Okay, the discriminator will identify whether it's a fake or real. Okay, so this is how the training process happens. So now let's try to understand what is the meaning of ANI, AGI, and ASI. Okay, so these are the broad classifications of AI, you can say. Okay, so one is called artificial narrow intelligence, okay, artificial general intelligence, and artificial super intelligence. So artificial narrow intelligence is basically designed to perform some specific tasks. Okay, so already we have achieved this. So most of the applications which you currently, okay, already it is able to perform certain tasks. Okay, all those applications comes under the ANI. So when I say ANI, basically, so the model or the application is trying to do one single task. Okay, so if those applications comes under this category, then we say it's a artificial narrow intelligence. So next we have a general intelligence. Okay, so which is able to perform more than one task. Okay, and can behave in like how the human behaves. Okay, so this is what the AGI is. So ASI, okay, so which is actually, there are a lot of research happening in this particular field. So here we have the emotions. Okay, of course it will do same task, okay, whatever the AGI is performing, I mean like multitasking, but along with that, okay, so it is much smarter than the humans, and it will have the emotions. Okay, so this is what the ASI is. Okay, just remember these are the three categories of AI. Okay? One is ANI, narrow intelligence, general intelligence, and the super intelligence. Just to summarize, so artificial general intelligence exhibits intelligence like human, right? Like it has a scope of knowledge, reasoning across the domains, then social skills, okay, creative thinking, and other cognitive competencies like vision and the language. So based on this, okay, whatever we have learned so far, right, so we should be able to choose the right tool for our task. So we need to at least tell, okay, so whether this comes under discriminative models or the generative model, right? So whenever we want to predict tomorrow's weather, or if I want to categorize the books, okay, if I want to determine if the picture is puppy or the bagel's image, right, then we should be able to tell that, okay, this problem statements can be solved using the discriminative models. So whenever we have a requirement of to create a code for a website, okay, from scratch, or answer the unique customer service questions, or draw a picture of the cat, right? So all this comes under the generative AI. And the general intelligence is just a complete traditional human jobs. Okay, so we should be able to at least based on the task. Okay, so we need to choose the right tool for the whatever the job we have selected. All right, so now let's discuss the evolution of the generative AI. So generative AI have become a hot topic in 2023. So all thanks to the chat GPT. So this chatbot reached 100 million users in just 2 months. Okay, so which break all records which was set by the social media platforms like TikTok and Instagram. So now let's discuss some of the key factors driving the development of the generative AI. So first is the better computing power. That is, the computers become the faster and more efficient. So next we had an access to more data. So that is the because of the data set availability, right? So next is competitive interest. Many tech companies and the governments are pushed for the better AI to stay ahead, and of course the model designs. So these are the major key factors which help the generative AI to grow faster. So now let's discuss how AI models today are far more powerful than they were 10 years ago. So this is all because of the parallelism. Okay, so parallelism is basically you can just define like the computers can perform many tasks at the same time. Okay, so it's all because of this graphics processing units that we call as the GPUs, and we have the TPU, that is a tensor processing units. Okay, because of this, now the computers can process the task, process the computations, and we can perform the task in a parallel. Okay, and next is cloud computing. So many researchers rent powerful computers in the cloud like AWS, Azure, and GCP, right? So, and the next is hardware software optimizations. Okay, so this you can say it's just a backbone of the generative AI. So next is the fuel for AI, that is the data, right? So in recent years, the amount of available data has exploded. You can even generate some synthetic data as well, right? So you can just grow, just you can see the amount of data that is being grown. Okay, it's in its zettabytes. Okay, so and in 2025, even it grows much faster. Okay, so. And these are the competitive pressures increase faster development, right? So it's all the companies who are competing with each other, right? Google, Meta, Amazon, and various companies. So now let's discuss how AI models become faster. Okay, so which we have seen already, right? So one of the thing is GANs, right? So which was introduced in the 2014. So GANs work like a competition between the two models. Okay, so one tries to create a realistic data and other judges it, that is a discriminator. So this technique dramatically improved the quality of generated image, videos, and other data as well. So next we have the transformers. Okay, so these AI models are like a super smart readers. Okay, instead of understanding one word at a time, so they grabs the meaning of entire sentence or a paragraph. Okay, this was the major advancements in the large language models. So next is reinforcement learning with human feedback. Okay, so this method helps the AI improve by learning from the users. So what is meaning of reinforcement? So here the AI tries the different approaches and learns from the mistakes. So next we have the human feedback. So here the people rate the AI answers or the outputs, and this feedback helps the model understand what works and what doesn't. Okay, so because of this, so there was much more advancement in the AI chatbots. Let me just show an example for that. Okay, if I just go and check here Google Gemini app. Okay, so here if I just get into this, and if I just tell here, so what is data science, just let me just enter some question here. Okay, so I'll be getting some kind of response, and this is what the RLHF. Okay, so that is a reinforcement learning with the human feedback. So based on this feedback, okay, so it will keep on learning it. Okay, so this was because of this, so there was a lot of advancement, because so it's not a one or two response. Okay, there will be millions of people who will be using and will be providing this kind of responses. Okay, and yes, so this is all about the factors, you can say, which is basically contributed to the generative AI. So yes, even in the even if you're using the Mid Journey or any other applications, okay, applications nowadays, we have this RLHF. Okay, so which will basically take the user feedback. Yes, so now let's start with the concepts of LLMs. Okay, let's try to understand what is the meaning of large language models are. So just to summarize, so we started with the AI, right? So what is AI? So AI is basically a broader umbrella which mimics the human behavior. So then we had a machine learning. Okay, so just it's all about making the data to learn from where we are making machines to learn from the data, like either a classification or regression task. So then we had the deep learning. Okay, we are changing the techniques. Okay, so we are making a machines to learn how the human learn. So then we had the natural language processing, which basically understand the human language. Okay, so again, it has many subtasks within the natural language processing, like language translations or text summarizations, right? And large language models is the overlap between the deep learning as well as the natural language processing. It's similar to generative AI. Okay, so whenever we are talking about the generative AI, we are talking about the large language models. So now let's try to understand what is the meaning of large language models. Okay, so let's start with the large. So it starts with the large, right? So whenever we are referring to the large, it means that these models, okay, has been trained on huge amount of data. Okay, so it has a huge training data and the resources. So next we have the language. So this models is able to understand the human like text. Okay, whether it could be any language. Okay, Kannada, Tamil, Telugu, or whatever the Indian languages or any other languages. Okay, so it is able to understand. Okay, so model is able to understand the human language, and the models, yes. So this models will able to understand the complex patterns, okay, which has been used in the textual data. So this is what the meaning of large language models is. Okay. So large represents the huge amount of data, and the language represents that the model is able to understand the different types of textual data or the language, and the models is basically able to learn the complex pattern using this textual data. So these are these popular language generators, okay, like ChatGPT. It's from the OpenAI. We have the Google Bard, okay, Hugging Chat, okay, it's open source. You can say Hugging Face, right? So these are the different examples, okay, best AI chatbots. You can just explore this, okay. If you're interested, you can just open this particular website and try to explore all this. And these are some of the milestone LLM models, okay. With the BERT, okay, so which is from the Google. It's called bidirectional encoder representation from transformers, which was developed by the Google. So then we had the GPT, which stands for the generative pre-trained transformers. This model was developed by the OpenAI. So next we had the XLM, okay, T5, okay, then Megatron, like it's from the NVIDIA, right? So these are some of the milestone LLM models. So yes, you can just explore like ChatGPT, Gemini, and the Bing Chat. Okay, so these are the popular chatbots. Okay, AI chatbots. So now let's discuss some of the applications of the large language models. Okay, because so it's overlap between the deep learning as well as the natural language processing, and most of the tasks comes under the natural language processing. Okay, like sentiment analysis. So based on if I want to give an example for sentiment analysis, assume like you have the Amazon reviews. Okay, or any other if you have a set of reviews. Okay, if you want to just tell whether what is the overall feedback of the customer, I mean, like, with respect to the product. Okay, whether they have the good sentiment or bad sentiment. Okay, or you can just if you have the X app, right? So from there, if you want to understand the public opinion, okay, so I can do the sentiment analysis based on that. So next, identifying the themes. Okay, translating the language from one language to another, like we have the Google Translate, right? So generating the code, again, expert predictions. Okay, so all these things are the applications of the large language models. So let's break down this. So with respect to the different business opportunities. Okay, so like automate tasks, okay, improve efficiency, create revenue streams, okay, enable the new capabilities, of course, right? So irrespective of whatever the industries you are, okay, so we can just use the generative AI concepts, or I mean like the generative AI tools and technologies. So this is with respect to the finance industry. Assume like we have the different types of data, right? So investment, it could be in the Outlook, annual reports, okay, news articles and social media posts, right? So we need to have all this data to make certain decisions, right? So that's where we can use the large language models to process all this, and based on that I can do the market analysis. Okay, I can build a portfolio management, investment opportunities. Okay, so this is where I can use the LLMs, okay, to which will help our business to grow faster. So in the healthcare, okay, so for example, like we have the doctor notes, like it has the different jargons, right? So whatever the keywords the doctor is writing, will not able to understand properly, or some kind of abbreviations. Okay, so it has some domain expertise, right? So it of course each doctor has a different writing styles. Okay, there are a lot of challenges. Okay, so we can just solve this challenges by using the LLM. Okay, by integrating the LLM. So based on this, so I can have the feature integrated with our applications, like personalized recommendations. Okay, so this is how we can integrate the LLM in our applications, in the websites or Android apps or whatever the applications you're building in. So in terms of education, yes, we can have the personalized coaching and feedback. Okay, so you can learn any concept. Okay, so using the AI chatbots. Okay, you can feel free to ask the doubts n number of times. Okay, you'll get many such examples. Okay, simpler examples, and you can just ask the LLMs to explain you the concepts in much simpler terms, right? So this is how we can use that in the education. Text generation. Okay, so this is what the many people use, right? So if you want to ask any questions or anything, okay, this is just a simple example just to explain like how for example, if I'm asking like explain why Pluto is not considered as a planet to 5-year-old, you can see this is what the explanation given by the LLM. And if the same question, if I ask, like assume like you are a astronomer expert, you can see we have the different explanation for that. Okay, so what I mean to say here is like based on the prompt you're giving, okay, LLM will be able to understand that, okay, and will give the response based on your requirements. So next, now let's discuss something called multi-model and non-multi-model. This is very important, okay, because whenever you're dealing with the LLMs, we should be able to classify whether it's a multi-model or a non-multi-model. So whenever we are referring to the multi-model, it means that we are able to perform the multiple tasks, okay. So at the same time, okay, you can say like many types of processing or generations we under the multi-model, and non-multi-model is just focused, that particular model is focused only on the single task, okay, or one type of processing or the generation, okay. So this is what the difference between the multi-model and non-multi-model. Like some of the example, like visual question answering, okay. So we have the visual, I'm uploading the image over here, then I'm asking certain questions, okay, textual data, so I'm able to get the response, right. This is the multitasking, okay. Yes, so there are some of the examples, okay. So now let's discuss some of the challenges, okay, which is faced by the large language models. So one is the sequence, okay. Of course, like whatever the prompts you're giving, or whatever the textual data we have, okay, so the model has to carefully understand the sequence, okay. So these are some of the challenges, okay, faced by the large language models. So it's more of conceptual, because when you know the LNP concept, like transformers, about RNNs, okay, so all these architectures, if you have explored, okay, you would have understood like why this sequence are very important. So just to give an idea, okay, so you can see like this is the state, this is the sentence we have, like I only follow a healthy lifestyle. So if I just try to replace this only before, like only I follow a healthy lifestyle, there is a lot of difference between this, right, based on the position of this word only, okay. So we have the different meanings, so that's way the sequence matters, okay. So the LLMs has to capture this particular sequences as well, right. So next is context modeling. So just to understand this, okay, assume like these are the we have the run, right. So the run can be used in the various context, okay. So for example, run to jog, okay, it's totally different thing. Run to manage is totally different thing, and run to operate is totally different thing. So what I mean to here is like if I say like run to jog, I'm basically referring to the marathon, right. So I run a marathon every year, okay. So you can see this run is used in a different context, okay. So this context has to be understood by the LLMs, okay. These are some of the challenges, okay, so which is faced by the LLMs. So one is the whatever I discussed, the sequence, right, and the next is the context modeling. So next example is the to manage, right. So I run a non-profit organization. So here the run is totally different, okay. This run is basically used in different context. So next, to do you know like how to run this machine, okay. So here the run is totally different thing. Of course, this run is not, I'm not referring to the marathon run, right. So this is what the meaning of context modeling is, okay, which is one of the challenges of the LLMs. So next, very important, that is a long range dependencies, okay. If you have already know about the LSTMs, okay, so this is there is a long history, okay. So before getting into LLMs, okay, there were other architectures, so which basically contributed to the transformers and whatever the advancements currently we have, okay. So one of the challenges is long range dependencies, okay. For example, so here this is the sentence, okay. The book that the young girl who had just returned from her vacation carefully placed on the shelf was quite heavy. So now this quite heavy was referring to the book, okay. So the model should able to understand, okay, so this quite heavy is referring to this particular book, okay. So this is the long range dependencies. So yes, so this is single task learning, which I was talking about, the non-multi model, right. So we have the task one model, right, so which will basically do one type of a task like question answering, okay. Or it can do some text summarization, okay, or it can perform the language translation, okay. So all these are single task learning. So multitask is basically we have the LLMs. So LLMs can perform the many applications, okay, I mean like many tasks. So we can do image captioning, okay, so we can do a text summarization. I can ask the model to translate something, okay. So everything can be done by the single LM, okay. So this is an examples, okay. So there are could be some models which is trying to perform one single task. If you are using the question answering model, so of course you're not able to do the language translation, okay. So that's what I mean, okay. So whenever we're referring to the single task learning, we are focused more on the one single task. So whenever we learn focused when we're talking about the multitask, okay, or basically the LLM which is able to do the multitasking or multi-model, okay, even we count that as a multi-model. Yes, to summarize, so these are some of the challenges of the large language modeling. Just to remember, okay, please remember this: there's word sequences, understanding the context, and the large range dependencies. Even we have explored what is the single task learning, that is task specific, right? So it is less flexible and a traditional model and early LLMs, okay, so which was doing the single task. So what about multitask? It's a versatile, okay, it can perform any task. There's a multiple task, and it is more advanced LLMs. So it has more advanced LLMs. Yes, so this is all about the large language models. We're gonna explore more about the generative AI concepts, okay, so in our upcoming videos. So mostly in the next video we'll try to do the setup, okay, so that going forward, whatever the tools or IDs we require, okay, so we'll be doing the setup in the next session. So see you soon, and if you liking my content, please subscribe it. And yes, thank you for watching.